Hello, in this video we're going to be talking about the roots of a plant, so let's not waste any of your time. Let's get right to it. Now, when we're talking about roots of a plant, we want to start off by talking about the two main types, and then we'll talk about later on in this video other styles of these two types. But you got your taproot, that's your long, deep, individual, thick root. If you've ever had to remove a bush, I know plenty of times. With the gardens that my wife has around, she's like, you know what, that bush ain't doing so well anymore. We're gonna get rid of that. She doesn't mean that we're gonna get rid of it. She means that I'm gonna get rid of it. Or if you've ever had to, like we had a small cedar tree die one year, and you've got to get that out, and you've got to find those taproots. And there's not just one central one. I mean, so you guys got to keep working around if you want to get all that out of there. That's your taproot, and it's not always in a plant. It's not always a hardened, woody feature. If you think about a carrot, things like that, those can be considered taproots. The fibrous roots. This is like what grass would do. This is why it's if you got a thick lawn and you want to dig into it. I mean, it takes a little bit of effort because these roots, even though they're thin, they're pretty strong and they are everywhere. I mean, it just completely fills in the process, the ground, I should say. Pretty sturdy stuff there. That's the fibrous roots. Fibrous roots are obviously along the surface, designed to get that rain, that water that's at the top couple inches of the soil. And of course, in the taproots are designed to get water that is deeper into. And taproots are also for strength, for an anchor, which is why you just can't push a tree over. But they're all designed to anchor plants and to, and of course, they store starches in plants or in the roots as well. For one, trying to keep them away. I mean, they're not trying to keep them away from the herbivores. They're not aware of herbivores. But that is one of the defense mechanisms that plants have, is to store a lot of their starches underground. All right, if we're thinking about roots, and this is a two-part list. There's 1, 2, and 3 on this slide, and 4, 5, and 6 on the next slide. So just prepare yourself for that, and you can kind of follow along as I work around the diagram. Beside me, this diagram will also be on the next slide as well. But if you want to think about roots and the root caps are pretty important. They got a couple important functions. One, protection. I mean, when you're digging through the soil, you're a root trying to work your way through the soil. You're going to come across rocks. You're going to come across other things that are in there, and you got to have a little bit of strength to you to make sure that you survive. In the next video, when we talk about tropisms and growth hormones, we're going to see that, especially things that are associated with gravitorism and hydrotropism, the auxins that are in plants that help them grow toward the particular stimulus. They can be in the root caps, and whether if it's gravity based, growing toward gravity or downward, or if it's water, they essentially, wherever the stimulus is located, they get on the other side, and it's like they're pushing in this case the root towards that. But any growth aspect, as you saw on the slide, we talked about primary growth, secondary growth. Those are called meristem areas. Anytime you see the word meristem associated with a plant, that is a area, tissue area, where growth is associated with. So the root, as it grows, it's got that meristem layer, and you can see that down toward that bluish section. It's the second section from the bottom, right above the root cap. Your zone of elongation, just like it says, this is the part to where the root will grow downward. If you think about this area, when it comes to a tree, trees that grow out, the zone of elongation is along the edge because they grow outward. They don't grow from the center, pushing. I'm sorry, that's what I was misspeaking. That's what they do. They push out, so that making those rings. But the zone of elongation, I butchered that a little bit there. It's the area where new cells are produced, which in turn make the plant wider, taller, or the roots longer in this case. This is also where if they now it says elongate prior to differentiation, and you're getting ready to see zone of maturation where they actually differ into different types of cells. So don't be confused thinking they're both differentiation. They elongate prior to differentiation. Alright, and this is part 2 of our list. Zone of maturization, this is what I was just talking about. This is where cells differentiate into the different types. So maybe it's going to be parenchyma, parenchyma, parenchyma. Maybe it's going to be ground, vascular, epidermis, dermal tissue, whatever it's going to differentiate into. This is where it happens. And this zone of maturation, if you're following along, is the kind of the pinkish, purplish stuff. They're kind of in the middle. And then you get your root hairs, which there isn't one. Well, it does mention them at the very top, but there's one or two there. But those are little extensions, kind of like fingers that come off the main root. And they're also able to absorb water. So you've got that root growing down, but it also puts out root hairs to kind of increase that surface area with the purpose of taking up water. And of course you got your vascular cylinder. That's the center. That's where your xylem and phloem is. And you may be thinking, phloem way down here? Well, it wouldn't be so much to make photosynthetic sugars, but it's to bring them down to the root for energy sources. But certainly your xylem will be at work uptaking water and processing it through the rest of the plant. Now, I mentioned this slide earlier, other types of or styles of roots. They're not true roots, so there's not like a third section, but they're just woody extensions for the most part, and they just have some direct benefit for the plant. Your epiphytic roots, these are roots that can kind of anchor plants onto another plant. If you've ever seen poison ivy, or if you were out in the woods and you see a very invasive honeysuckle has completely taken over an area, as they touch other plants, they can put out these epiphytic roots that help them to kind of grab on and hold on to, almost tendril-like. Prop roots. If you've ever seen swamp area type trees, I think it's the cypress, the bald cypress is the most common of this around here, where not only they have their root systems underground, but they put out these little supporting roots to kind of help to keep the plant upright. Those are called prop roots. Advantageous roots. These are roots that can just kind of grow out from just the regular body of the plant. whether it's support, whether it's keeping balance, giving it strength and standing up, advantageous roots. And then aerial roots are roots that grow on the above ground part. They come out straight from the stem, straight from the stalks or whatever. Aerial roots. They don't reach into the sky, but they're part above the ground that grow out. Well, that's our video over the roots of a plant. When we come back together next time, we're going to be talking about tropisms and growth hormones. We'll see you then.